Hi guys, today we're looking at inequalities. So let's try to look at our first example here. Our first example, so this is our example 1. So we're looking at 2x plus 2 is less than or equal to 1. Check the same as solving for x. So that therefore we can say we have 2x less than equal to 1 minus 2, that therefore we have 2x less than or equal to minus 1. We divide by minus 2, we divide by 2, divide by 2, that therefore our x is less than or equal to minus half. Okay, but this case we have to present it to the number line. Let's say our number 9 here, so we have to draw a number line. Let's draw it here, a line. Let's draw a number line here. This is our number line. Okay, so what we do with our number 9, we always have 0. You can always say we have 0 here, so this is our 0, or we can just do it like that. At least let's try to do it like that. So say we have 0, we have 1, we have 2, we have 3, so this would be minus 1, minus 2, minus 3. Okay, so this is our number line. This is our number line. It carries on. So it starts from 0 going to 3, and you can carry on, or from 0 to minus 3 it can go on. So what is happening? We're looking at half. Half should be here. So half should be here. So our half is here. So we just circle here where the half is. So this is our minus half. So we're looking at all the x's, or the x value that are, so x they're saying is less than half. The numbers that are less than half are from this side going that side, so it's all less than half. So it goes to infinite, so it's all goes to half. Because we're saying x is less than or equal to half, so we need to shade this one here. We need to shade it like that. But you see, basically if you're looking at an interval part of it, so our interval will be like this. It's from negative infinite to half, negative infinite to half. Then we close the bracket because we're saying that it's less than or equal to. So the closed bracket means inclusive. It means it include half or include negative half. That was our first example. Let's look at our second example. Our second example will look like, so our second example will have 6 minus r less than 2, so we can look at this as we're saying we have 6 minus 2 less than r. Okay, this is 4 less than r. So we're looking at 4 less than r. Then we look at our number line. Let's quickly look at our number line. So if you look at our number line will be like that. So let's look at we're looking at 4. So this should, if this is 0, 1, 2, 3, 4, 5. So this is our r. This is our r, and we're saying r is greater than 4. So our 4 is here. Let's look at our 4. So we have to circle it here. So this is our 4. All r is less than, or r is less than 4. So all values that are less than 4 So we'll be looking at this one, these values, all these values here. We're saying all these values going that side downward. This can include -1, etc. So this was the second example. Let's look at another one, the third example. Our third example, let's look at 4x plus 3 less than 2 into x plus 3. So we need to expand first. So this works the same as solving for x, because we can have 4x plus 3 is less than 2x plus 6. But therefore we have 4x minus 2x less than 6 minus 3. That therefore we have 2x less than 2x less than 3, and x is less than 3 is less than 3 over 2. Sorry. Okay, so we're looking at our number line. Let's say our number line will look like something like that, and then we have this is our x, this is our x, then we're looking at x, we're looking at 1 over, so let's say you have 0, 1, 2, 3, and then 2 over 3 should be somewhere around here, but we're saying that x is less than that, so x is less than all this here. When you can see, because x is not included, it's just x less than 2 over 3, so we're not shading it, we leave it open. So we're leaving it open. So if you're looking at the interval part of it, this can be minus infinite is 2, minus infinite is 2, 3 over 2. Okay, normally we write it, we say x is an element of that, to say that x lies within this interval. And you see we have our open bracket here, it's not closed because it's not included if you're looking at this one here. Okay, so let's look at the next example. Our next example, which is example 4, will be, let's look at 3 into x minus 8 into minus 2 minus 2 less than or equal to 2x plus 2. Okay, so what we're doing here, we need to expand that. Therefore we have 3x minus 24 minus 2 less than or equal to 2x plus 2. Okay, so what we can say that therefore we have 3x minus 2 minus 2x less than or equal to 2 minus 26. So this is minus 26, but therefore we have x less than or equal to minus 24. Now if you're taking that, that should be plus 26, so we have plus here, we have plus 28, so we have x is less than 28, because when we're taking these two, taking it to the other side should give you positive. So let's look at our number line then we have something like this. There's our number line. Okay, so here we're looking at we can have 20, 28, 29, 30, etc. Then we can have 27, 26, etc. So we're looking at 28. So this goes like that, then that goes like that. We're looking at 28 inclusive, so 28 is open and x is less than that, so we're looking at all this less than 28, and then we're saying x include that one. So if we were looking at the interval, then our interval will be like x is an element of negative infinite to 28, and then we put a closed bracket because of this, or less than or equal to, it means it is inclusive. Okay, thank you very much for watching.